Hey, it's Jacob. Welcome to this new video. Today, I want to talk about not being fooled about the details when learning AIs, because there are tons of things that you don't need to learn. And this video particularly is about the things that not only they're not useful, are they not useful, but like they are counterproductive for your for what you want to do. They're gonna have a negative impact on your learning, and that is really important. That might be a little bit counterintuitive because you might think, well, I mean, if I work a lot and if I learn, if I spend a lot of time, then it's a good thing, right? The more time I invest, the better I am, right? That might seem like it makes sense in that way, but in the reality it doesn't actually work that like that. And I'm going to give you an example right now just to explain to you and why that is. And also, like, there is a specific experiment that I want to talk about that actually shows that sometimes when you're doing things, when you're working, it has a counterproductive impact on what you do. At the end of it, you're worse off than when you didn't learn anything, when you didn't work at all. So here, let's talk about like building a computer. Like if you want to build a computer, then what are you going to do? Are you going to learn about resistors, transistors, integrated circuits? Or are you gonna ask on a forum like what do I need? Like which type of like RAM, which type of CPU or GPU do I need in order to solve my problem, which is like building a computer? Well, it's probably going to be the latter, right? It's going to be like RAM, CPU, GPUs, and all that, right? It's not going to be learning about resistors, transistors, and integrated circuits, even though that's what a computer is made of, right? But what is the problem here? Why would you why is it not a good thing to learn about resistors and transistors and things like that? Well, it's not necessarily a bad thing, but it's not going to help because it's not the right level of abstraction for what you're trying to do. If what you're trying to do is to build a CPU, then maybe learning about electrical engineering is going to matter. But if what you're trying to do is building a computer, then that's not going to help. So that's why I want to talk about like an experiment here that explains basically the psychological impact that it has to do that thing, right? Because when you are doing something that is impossible, it is not neutral. It's not going to have a neutral impact on you. It's going to have a negative impact. So an experiment was conducted by Dweck and Rapucci in 1973. And this experiment showed that the exams that are given to students, when they are impossible exams, then those very same students, they are not able to solve or to do the exams of their level. So that doing that is basically like making them learn that they cannot do the exams. And because they have integrated that learning, then it has become extremely a lot more difficult to do things that are at their level. So it's kind of the same idea as like learned helplessness. This is basically that, right? Like if you keep reinforcing those pathways that you cannot basically solve things that you want to do, then it's a dangerous path because, again, it's going to reinforce that path. And then you're going to keep getting used to not being able to solve those problems. When this is because you don't have the right level of abstraction, or like it's basically the same as like jargon, right? Because if you're looking at like even in AI, like you're looking at very specific things within AIs, like for example, we can talk about derivatives because like when you're training a neural network, when you're training an AI, well, at some point there is going to be some type of gradient descent, which is based on like derivatives of a loss function. So yeah, sure, derivatives, they are part of AI, right? But like at the same time, it's the same thing as resistors, as a transistor. A transistor is part of a computer, but do you actually need it to build a computer? And this is basically like the idea here. Do not learn about words or jargon that don't matter, And how do you know if you're in that case or not when you're learning? Well, look at like try to understand things from any source, but like look at whether or not like each word is explained in a simple way that you can understand. Because if they are using jargon that you don't understand, then that means it's not at the right level of abstraction. You need to start at the right level. So, as an example, like I'm also a math tutor, so I help students with math, and I would rather a student that knows about like a few formulas, but like they actually know them extremely well, meaning they know when to apply those formulas, like how to solve the problems, what are they used for, and then actually apply that formula. But like a student that has learned about all, like they have heard about all those things, all those different like theorems and basically like formulas and stuff like that. They if they have heard about those, but like they have no idea how to apply them or what they are used for, then it's not going to it's going to come back to basically have given an exam that is impossible to do, right? Because they are trying to do something but they don't have the tools. When if you only know a few things, that means it's maybe you're not going to be able to do everything like all the way. However, you're going to do at least the things you know how to do, and then you can build on that and learn those other things. But if you know a little bit of everything but you have no idea, you have no depth on like how to apply them, then it's really not going to matter. Like it's going to, it's not that it's not going to matter, it's again it's going to have a counterproductive impact on your learning. So that's basically the idea here. So let me clear that up and give you, like, if I have just one advice to give you, is basically learn less jargon, but learn it in more depth, basically. So less, let me remove that. So less jargon, more depth. Okay, so let me emphasize this one. So basically here, this is like what I'm doing also. Like I don't learn a lot of things that I don't understand. Like if I don't understand it, then I'm going to, if I talk to an engineer or somebody and they use like weird jargon words, all I do is I ask and I put the burden of the explanation on them. They have to make me understand what they were talking about. And if you start doing that, you are going to realize they don't know what they are talking about. Like sometimes they use jargon just to use jargon because they know that it's almost like a defense mechanism, because they know that if people can understand things, then they cannot be judged on like what they know, because like they are not gonna understand what they are talking about. And most people don't ask. It's just like how like the situation, the social situation is just like it tends to make people not ask, right? Because the people don't want to feel dumb. So put the burden of the explanation on the person that uses the jargon, not the other way around. And this is because then they have to explain it in simple words and come back to the words that you understand. And again, if they can't do that, then that probably means that they're using the like jargon just to feel smart or to seem smart, but they don't actually know what they're talking about. So be careful, because it can have a very negative impact on what you're trying to do. So it's important to be careful about that. So that's pretty much it for this video. If you want to be part of my contacts, click on the link in the description, and you'll get free content from me, exclusive content from me. So thank you for watching, and see you in the next one.